The foundation of the world's largest automaker were not laid by an automotive engineer, by a master of carpenter and inventor named Sakichi Toyoda. Born in 1867 in a rural farming community, Sakichi possessed a rare innate genius for mechanical design. At the turn of the century, the weaving industry in Japan was entirely manual, labor-intensive, and plagued by quality issues. If a single thread snapped on a manual loom, the machine would keep weaving, producing yards of defective, ruined fabric before the operator noticed. Sakichi set out to solve this, and in 1926 he perfected his masterpiece, the Toyoda G-type automatic loom. It was a marvel of mechanical automation. The machine could change shuttles without stopping, but its true stroke of genius was an integrated mechanical sensor. If a single thread broke, the loom instantly locked up and shut down. Sakichi called this concept Jidoka, automation with a human touch. The philosophy was simple: never allow a machine to create a defect, and never force a human worker to mindlessly wash a machine that is operating correctly. And this single invention was so revolutionary, the premier British textile firm Platt Brothers bought the patent right to the loom in 1929 for a staggering 100k British pound, which is a lot back in the days. Sakichi's son Kishiro Toyoda watched this transformation closely. Kishiro was a graduate of Tokyo Imperial University with a degree in mechanical engineering. In the late 1920s, financed by his father, Kishiro traveled extensively through Europe and the United States. He stood on the factory floors of Henry Ford in Detroit. I think it's the Ford, that the car brand Ford we know today, and watching a relentless river of black Model T sedans rolling off the line. Kishiro became utterly consumed by a singular, audacious obsession. Japan must build its own domestic automotive industry. When Sakichi Toyoda passed away in 1930, his final wish to his son was clear: use the capital from the loom patent to build an automobile company. And in 1933, Kishiro officially established an automotive department within the Toyoda automatic loom work. The task was monumental. Japan lacked a reliable supply chain for high-grade steel, electrical component, or precision casting. Kishiro and his small teams bought American cars, stripped them down to the bare chassis, and reverse engineered every single bolt, piston, and gear. They failed hundreds of times, casting engine blocks that cracked during cooling and forging gears that shattered under load. But by 1930, the persistence paid off. They unveiled the Toyota Model AA, a sleek, streamlined passenger sedan heavily inspired by the Chrysler Airfloat, powered by a reverse-engineered 3.4-liter overhead valve 6-cylinder engine. With a real car ready for production, the company prepared to split the automotive division into an independent entity. And in 1937, they ran a public competition to design a new corporate logo. Tens of thousands of entries poured in, but one design caught the eye of the executive board. It geometricized the character to read Toyota instead of Toyoda. The change was calculated and brilliant. In Japanese katakana script, writing the family name Toyoda required 10 distinct brush strokes, but writing the modified name Toyota requires exactly 8 strokes. In Japanese numerology, the character for 8 open outlets at the bottom, symbolizing an expanding path of growth, wealth, infinite prosperity. Furthermore, phonetically, Toyota sounds crispier, cleaner, and visually divorced the family's private life from the massive industrial responsibilities of the new corporation. On August 28, 1937, the Toyota Motor Company was officially. The optimism of 1937 was quickly swallowed by the fire of World War II. During the conflict, Toyota was forced to pivot entirely to produce austere, bare-bone military trucks for the Imperial Japanese Army. Material was so dangerously depleted that the late war trucks were built with only a single headlight mounted dead center on the grille by the wooden front brake instead of metal drums. By the time the war ended in August 1945, Toyota factory had been completely obliterated. Hyperinflation was rampant. The raw steel was practically non-existent. In 1950, the company faced a catastrophic financial meltdown. A severe cash shortage led to massive labor disputes, strikes, and the eventual resignation of Kiichiro Toyoda himself. The company was on life support. They were ordered by the Allied occupation force to produce vehicles, but they had to face a terrifying reality. A gap between Japanese and American industrial productivity was staggering. Kiichiro Toyoda issued a desperate rallying challenge to his remaining workforce. Catch up with America in 3 years, or the Japanese automotive industry will not survive. To achieve the impossible, a brilliant operational mastermind stepped forward from the matching stop, an engineer named Taiichi Ohno. Ohno looked at the American mass production system, the system pioneered by Henry Ford and perfected by General Motors, and realized it was fundamentally flawed for post-war Japan. America's strategy relied on economies of scale, building thousands of identical parts in massive batches, pushing them down the assembly line, and storing the excess inventory in Grangutan warehouse. This required immense capital, unhindered space, and an endless supply of raw material. Toyota had none of these things. If a batch of 10,000 stamped door had a hidden defect, the American system simply called it at the end of the line and scrapped it. Toyota couldn't afford to scrap a single piece of steel. Ohno decided to create an entirely new paradigm of manufacturing. He called it the absolute elimination of muda, the Japanese word for waste. He identified 7 deadly wastes in the factory: overproduction, wasting time, unnecessary transportation, overprocessing, excess inventory, wasted motion, and the production of defective parts. To eradicate these wastes, Ohno designed the Toyota Production System, TPS, often represented as a structural house built on 2 structural pillars. The first pillar was just in time. Ohno actually found the inspiration for this not inside an auto plant, but inside an American supermarket during a study tour. He observed that a shopkeeper walks down an aisle, pulls 3 cans of milk off the shelf, and walks to the register. The supermarket clerk sees the empty space and replaces exactly 3 cartons of milk. Ohno applied this exact concept to the automotive assembly line, creating a pull system. Instead of an early station pushing parts down onto the next worker, a station will only manufacture a component where downstream worker reached backward and requested it. To coordinate this, they used a physical card system called Kanban. A card was attached to a bin of parts. When the bin was empty, the card was sent back to the authorized and production of exactly one more bin. This completely dismantled the need for storage warehouse. The entire factory operated as a single, lean, breathing organism. The second pillar was modern evolution of his father's invention, Jidoka, or automation with a human touch. Ono installed a physical rope along the entire ceiling of the assembly line, the Anden cord. He implemented a rule that shocked the global manufacturing world. If any line worker discovered a defect, a stripped thread, or a faulty weld, they were instructed to pull that cord instantly. An overhead light board would illuminate, an alarm would sound, and the entire multi-million-dollar factory line would grind to an absolute halt. In Western factories, stopping the line was considered a treasonous act and that destroyed profit. But Ono understood that if you don't stop the line to fix the problem at the root cause, it was simply passing a defect down the line where it becomes exponentially more expensive to fix later. By freezing the line, engineers and workers rushed to the station, solved the issue immediately, and implemented Kaizen, continuous incremental improvement, to ensure that specific error could never happen again. The implementation of TPS transformed Toyota. By the 1960s and 1970s. Their efficiency was unmatched. When the global OPEC oil crisis struck in 1973, fuel prices skyrocketed, and American consumers abandoned their massive gas-guzzling V8 lanyards. They turned to the market and discovered the Toyota Corolla, which had debuted in 1966. It wasn't just a cheap, fuel efficient, it was assembled with a level of surgical precision and reliability that American manufacturing simply couldn't replicate. The underdog from Nagoya had officially caught up to and shaken the foundation of Detroit. By the late 1980s, the Toyota production system had turned the automaker into an absolute financial titan. Concurrently, Japan was experiencing the bubble economy, an era of astronomical financial wealth, soaring real estate values, and boundless corporate confidence. Money was no object, and Toyota's executive board decided it was time to move beyond utilitarian commuter cars. They gave the elite engineers team a blank check and a clear mandate: build vehicles that will show the world that an absolute outer limit of Japanese technical prowess. This ushered in the legendary golden age of Japanese domestic market, the JDM era. Toyota's first cultural icon of this period looked entirely unassuming. It was a rear-wheel drive compact coupe called the AE86, sold as the Corolla 11 and the Sprinter Torino. It didn't possess a massive engine. Instead, it relied on a high-revving twin-cam 1.6-liter four-cylinder engine known as the 4AGE. Developed in partnership with Yamaha, the 4AGE featured an electric fuel injection system and a Ford Motorsport derived exhaust note. But what makes the AE86 a legend wasn't raw speed, it was the balance. Weighing just under 2,100 pounds with a perfectly tuned front engine, rear-wheel drive layout, the car possessed a level of telepathic steering feedback. On the narrow, twisting mountain, discovered that the AE86 could out-corner, out-maneuver, and outdrift sports car with triple its power. Guided by real-life racing driver like Keiichi Tsuchiya, aka the Drift King, the AE86 birthed the modern sports. Competitive drifting was immortalized across global youth culture through the anime Initial D, and most of you might have watched it already. But Toyota's ultimate statement of engineering dominance arrived in 1993 with the launch of fourth-generation A80 Supra. The primary architect of the A80 Supra, chief engineer Isao Suzuki, set out to build a car that could clear a path straight through the high-speed T of European supercar. To achieve this, to be an absolute masterpiece of mechanical violence, the 2JZ GTE engine. The 2JZ was a 3.0-liter inline-six engine utilizing sequential twin turbochargers. On paper, due to strict gentleman's agreement between Japanese manufacturers to limit advertised performance for safety, the 2JZ was rated at exactly 276 horsepower. In reality, the engine was a wolf in sheep coating. Toyota's engineer has built the 2JZ not to sports car standard, but to heavy-duty industrial specification. While contemporary rivals were moving to lightweight aluminum engine blocks, Toyota built a 2JZ blocked out of dense, heavy casting iron. The cylinder block featured deep skirt geometry, and the forged steel crankshaft was supported by a massive 7-bearing main journal array. The cylinder head featured dual overhead camshaft and 4 valves per cylinder, optimized for high-volume airflow. When the global tuning community cracked open the 2JZ in the mid-1990s, they discovered a shocking reality. The factory bottom-end piston, connecting rods and craftsmanship were so radically over-engineered that they could handle massive structural load without a single modification. By simply bolting on a larger single turbocharger, upgrading the fuel injectors, and remapping the engine control unit, tuners could reliably extract 700 to 800 or even 1,000 horsepower from a completely stock internal engine block. The 2JZ became a culture phenomenon, dominating drag strips after drag strips, highway racing culture, and Hollywood cinema, cementing the A86 Supra as an immortal titan of automotive history. Toyota understood the street icons are born on the assembly line, but their souls are forged into the fires of competitive motorsport. They didn't view racing as a mere marketing exercise. They viewed it as an extreme laboratory where mechanical components were stressed to the absolute breaking point to gather pure engineering data. By the late 1980s and early 1990s, Toyota Team Europe TTE, operating out of Cologne, Germany, took aim at the World Rally Championship, or what you have heard of WRC. To win the brutal world of Group A rallying, you needed a car that could survive jumps, rocks, snow, and mud while maintaining terrifying speed. Toyota this time unleashed the Celica GT4. Powered by a highly advanced turbocharged 2.0-liter engine called the 3S GTE, mated to a permanent all-wheel drive system, the Celica GT4 shattered European dominance in the sport. Legendary drivers like Carlos Sainz, and not the F1 one but the different one, and Juha Kekkonen pushes the car to the absolute limit, capturing multiple drivers and manufacturers' world championships for Toyota. But as the 1995 seasons approached, the competition grew fierce. The sports governing body, the FIA, grew deeply concerned about the dangerous speed of the rally car. To slow them down and level the playing field, the FIA mandated a strict new rule. Every team had to install a steel turbo restrictor plate directly in front of the turbocharger's compressor wheel. This plate choked the engine intake air supply down to a diameter of 34 mm, effectively capping the output of roughly only 3,000 horsepower. Toyota engineers looked at this restriction and found themselves back into a corner. Instead of admitting defeat, they engineered a solution so dastardly brilliant and so deeply illegal it would trigger one of the greatest scandals in racing history. And I'm going to explain what's going to happen. During the 1995 Rally Catalonia, technical scrutineers for the FIA received an anonymous tips. They confiscated the turbochargers from the factory Toyota Celica S2205 cars and cut them open with precision steel. They discovered left the engine wood completely speechless. Toyota had created a highly complex spring-loaded bypass mechanism hidden inside the turbocharger's internal housing. When the car was turned off and sitting stationary in the pit lane for inspection, the restrictor plate sat perfectly in place, matching a full legal 34mm. However, when the driver stepped on the accelerator pedal out on the stage, the immense vacuum and air pressure generated by the spinning turbocharger engaged a series of hidden levers and Belleville washers inside and causing the casing. The entire internal assembly would slide backward by just 5mm. This mechanical shift opened up a secret, unrestricted, ring-shaped gap around the side of the restriction plate. This bypass allowed 25% more air to feed directly into the engine combustion chambers, completely neutralizing the FIA safety restriction. It handed Toyota an invisible, undetectable 50 horsepower advantage on every single stage. The system was crafted with such surgical precision, using a rubber-sealed joints and polished internal collars, that it left no external trace whatsoever. And of course, the president of FIA, Max Mosley at the time, was simultaneously appalled and deeply impressed. He stated publicly, "It is the most sophisticated, ingenious device I've seen in 30 years of motorsport. It was beautifully made inside. There was no hand fitting, no tool marks. It was a masterpiece of manufacturing." But engineering brilliance could not pardon cheating. The FIA stripped Toyota of all their points for the 1995 season and handed them factory team a severe one-year ban in the World Rally Championship. Toyota's motorsport reputation was dealt with a catastrophic blow, but the sheer genius of the device became a legendary testament to how far the engineer would go to achieve. From a single wooden automated loom that revolutionized the textile industry to a hyper-efficient manufacturing philosophy that changes every modern factory on Earth, from an era of over-engineered cast-iron street monster that defined the global car culture to an uncompromising racing resurgence that brought elite motorsport technology back to the public roads. Toyota's century-long journey is a masterclass in the power of continuous, relentless adaptation. They proved that a company can manufacture the most sensible, practical, and dependable commuter car parked on the street, while simultaneously engineering some of the most thrilling, complex, and victorious performance machines to ever turn a wheel on a racetrack. The secret to Toyota's empire isn't just their capital or their scale, it is their unwavering belief that absolute efficiency yields the power to achieve absolute genius and greatness. As the global automotive landscape stands on the precipice of its next major revolution, changing from fossil fuel to hydrogen and solid-state electrification, one historical truth remains completely undeniable. Whatever the future looks like, it will be navigated by an empire built on 8 strokes of absolute genius. And that's me talking about the history of Toyota today. If you enjoyed the video, don't forget to hype the video and like and subscribe down below. I'll see you guys next time. Next time we can do other stuff or some Chinese FH6, but just comment down below what do you want me to do next. I'll try my best to do it, and I'll see you guys